So this is section 9.6, part 5, the hopefully last part of this thing, some specific examples. So these are some examples from the homework section, the exercises of the Stewart-Kokoska. We're going to start with page 706, number 24. So we have this series, sum from n equals 1 to infinity of n pi to the n over negative 3 to the n minus 1. Who came up with that? I don't know. Maybe Stewart, maybe Kokoska, some crazy person. All right, so we look at that and we say none of our tests, you can think about them, none of them are going to work. One of the sort of key things is you see how, like this pi to the n and pi to the 3n minus 1, I could factor out a pi and get pi to the n minus 1 in the top as well. So I have sort of like a geometric series with r equals pi over 3 here, but then I have this polynomial, n, it's like a negative p series with a negative p. And I once again have those two things mixed together, and that's sort of the characteristic of why I'm going to use ratio test. So we're going to do ratio test on this. And for a ratio test, I need to look at, maybe I'll do a little bit of scratch work first before I go into the whole limit, and just look at what a sub n plus 1 over a sub n is. And that is, so I'm going to start by putting n plus 1 into every n up here. So my n is going to be n plus 1. And I'm going to parenthesize that, and then I have p to the n plus 1, and then the bottom I have negative 3, where I already had n to the n minus 1, so if I add 1 to that I'm going to get positive n. So that's just a sub n plus 1 right there, a sub n plus 1, and I need to multiply it by 1 over a sub n. So 1 over a sub n is, I'm just going to take this as it is and just flip it over. So I'm going to have negative 3 to the n minus 1 over n pi to the n. So you tend to get these things that are sort of really messy, and that's sort of the drawback of this. But they simplify pretty nicely. So I can cancel pi to the n plus 1 over pi to the n, just as we discussed before, becomes just pi. I can put together the n plus 1 and the n parts, so I have n plus 1 over n, and I can see that's going to go to 1. And then I have my pi to the n plus 1 over pi to the n is just going to give me pi. And then my negative 3 to the n minus 1, and I have one more negative 3 in the denominator than I do in the numerator, so that negative 3 ends up being in the denominator, negative 3. All right, now, like I have that negative 3 causing problems, but I'm really looking at the absolute value of a sub n plus 1 over a sub n, and that is equal to pi over 3 times n plus 1 over n. For some reason I switched the order, I don't know why, but the negative 3 I changed to positive 3 because I'm taking the absolute value. And I can do that because that's what the limit test requires, the ratio test requires, the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So now I can use my scratch work here and say I've worked out what that is. That's going to be the limit as n approaches infinity of pi over 3 times n plus 1 over n, and then I can just bring the pi over 3 out of the limit, have pi over 3 times the limit as n approaches infinity of n plus 1 over n, and limit as n plus 1 over n I can just do by comparison of the degrees, so that's pi over 3 times 1, which is pi over 3, and that is greater than 1, so that tells me that my sum from n equals 1 to infinity of n pi to the n over negative 3 to the n minus 1 diverges, because my limit came out to be greater than 1, so diverges by the ratio test. I do want to do a second example, but these videos tend to bite me if they get too long, so I'm going to stop there and we'll do one last video for one final example and your homework.